This video is being made to accompany the class notes on time value of money used in my managerial finance class, and perhaps even in Intermediate Accounting 1 class in the section on time value of money. This particular video is to accompany the notes that provide a brief introduction to time value of money, as well as how to use the TIBA2 Plus calculator to evaluate investments with uneven cash flow streams. The time value of money is one of the most pervasive concepts in the field of finance. That means it has a broad range of applications in valuing debt, valuing equity, really valuing any business. And there are two particular types of problems that I like to work with here, which I will show you in time. In evaluating any long-term investment, you have to apply time value of money methods. Well, there is an alternative, and that is to using sort of rules of thumb that may have developed over the years, but there are times when those rules of thumb, for instance, if someone says a piece of rental property is worth 10 times its annual rentals, you have to ask why 10 times? Why not 11? Why not 15 or 7? Why that particular rule of thumb? The time value of money techniques don't require the acceptance of arbitrary rules of thumb when it comes to valuation. It's a much more rigorous and sophisticated approach to valuation. There are 4 basic applications that we're going to learn to use. I call these building blocks for any type of investment or borrowing, and any type of problem that really involves time value of money principles. There are 2 ways to evaluate any and every investment using time value of money techniques. The first one is called the present value approach, by which we'll estimate the value of an investment and then compare that value to its cost. This is really the way most of us make consumption decisions all the time, as well as many purchasing decisions. You know what something costs, by the price. Very often the decision as to how whether it's worth it is a very subjective one. When it comes to business, we want to take that subjectivity out of it. And so we are determining the value of an investment as the present value of the future benefits, which are defined by the cash flows, that project is expected to provide. That doesn't mean that there's no uncertainty or risk. There always is. We're dealing with the future here. However, we will determine the present value by estimating the future cash flows provided by the investment, bringing those back to the present through the magic of discounting. And if the present value of the present value of the future benefits exceeds the present value of the cost, then it's a good investment. Otherwise, it's a bad investment. So the basic rule is, if an investment is worth more than it cost, it's good. Otherwise, it's bad. Sometimes we might apply this by calculating not the present value, but what's called the net present value. That's the difference between the present value of the future cash flows and the cost, which we generally designate as the initial outlay. In this sense, if the present value of the project or the asset is greater than the cost, then it's a good investment, and that difference, known as the net present value, will be positive. And so that's how we know a good investment using this particular twist on the present value approach, by solving for the NPV, and if the NPV is positive, then it's a good investment. The second way of evaluating investments using time value of money techniques is by calculating the internal rate of return. The IRR approach requires that we calculate the rate of return that we would expect to earn from the investment. We know that as the IRR, or internal rate of return, and we compare that rate to the required rate of return. Very often the required rate of return may be the best estimate of the cost of our funds. In other words, if, for instance, your money is costing you 5%, but a particular investment will return 7% using that money to finance it, then it's a good investment. The IRR exceeds the RRR, and that's what defines a good investment. And by the way, these 2 approaches will always give you the same yay or nay, the same accept or reject decision here. There will never be a situation where the NPV would be positive, that is, the project would be good by the present value or its variant net present value approach, and yet be poor or be a bad investment by the IRR approach. They will always give you the same accept or reject signal for a particular investment. Well, let's apply this. Hopefully you've got a TIBA2 Plus calculator or one of the many emulators that you can find that will work on your iPad. And so I'm going to show you how, or explain to you here, how to use your TIBA2 Plus calculator or the calculator version, the iPad version of that, to solve a particular problem. A local struggling business is for sale. The asking price is $145,000. Now, of course, that's what they're asking. That's the cost. It's not necessarily what it's worth. That's what you've got to determine. So let's say that you've estimated the cash flows after tax, CFAT, for this investment, including the initial outlay, operating cash flows, and the terminal cash flow shown on the timeline in the notes. Now, the year 4 cash flow after tax includes the proceeds from the sale of the business, so there's really nothing that project is expected to provide, that business is expected to provide beyond the 4th year. Let's say that you believe a 14% required rate of return is appropriate. That 14% required rate of return more or less represents your exchange rate between money today and money tomorrow. And so we're going to evaluate this investment by both approaches using the TIBA2 Plus calculator. There's a picture. I've eliminated the thousands here. But we have determined that the cost or the purchase price of this in business is $145,000. At the end of year 1, or let's say during year 1, we expect to generate positive cash flows from the operation of this investment of $53,000. In year 2, $66,000. Year 3, $65,000. And year 4, $46,000. And again, that last year, that 4th year cash flow includes not just the operating cash flows for that enterprise during the year, but also the terminal cash flow from sale of that asset at that time. Even though we know, by the way, that these cash flows would be generated throughout the year as you generate revenues and incur expenses, for our calculation purposes, we are going to pretend or assume that those cash flows occur at a specific date, namely the very last day of each year, so that $53,000 in year 1 is actually expected to come in on December 31st of that first year of operation, $66,000 at the end of the second year of operation, and so on. Now, in order to solve for this problem, we have to access the cash flow worksheet that is embedded in the calculator. So you will press the CF key in near the upper left side of this of your calculator. Now, there will be times when going from one problem to another, you'll want to clear out the calculator. So you'll need to do so, clear out the worksheet. To do so, you have to be in the worksheet. In other words, press the CF key, and then press the Shift or second key, also in the upper left-hand corner of the calculator, and then the Clear entry or clear key in the lower left-hand corner of the calculator. By doing that, then you're clearing out all the cells in the worksheet. It doesn't do any good simply to press the clear key. It may clear out the display, but it does not eliminate any values that are embedded in the worksheet or that had been installed in the worksheet. So it's always a good idea to start out with a clean worksheet when you have a new problem, so you're not maybe adding keeping some old numbers in there that you simply haven't, you're not aware of. Once you've opened the worksheet, insert the cash flow values into that worksheet by keying in the values, then pressing Enter, and then using the up and down arrow keys to move through the worksheet. So, when you open the worksheet, you'll be prompted for CF0. That's the cash flow at time 0, and that amount is $145,000 outlay. That's a negative, and that's how, of course, you would install negative values. Now, you can put let's say, key in a negative and then the 145,000 here, or install key in the $145,000 and then press the sign change key on the bottom row of the calculator. Either way, once you insert that value, you must press the Enter key to install that value in that particular cell. If you don't press the enter key and just go down the worksheet inserting values, then you'll go back and find out that you don't have any values in the worksheet. You have to press that enter key after you key in a value in order to install it in a particular cell. So we've got CF0 installed. The next thing is the $53,000. That C01 is prompting us for that first cash flow in this, in period 1. That's $53,000. We input that, and then we enter it. Now, F01 is prompting us for the frequency of each cash flow. In this case, it says, okay, that $53,000, that C01, that first cash flow, does that cash flow occur again in sequence? In other words, that $53,000 occurs in year 1. Does it also occur in year 2 and possibly in year 3? If the answer is no, the value that follows that is not $53,000, then the frequency of that $53,000 value is only 1. Now that happens to be the default setting, so it's already in there. You can just scroll down using the down arrow key and ignore that frequency key in many cases, because in most problems we're not going to have to use that frequency. It's always going to be 1. In other words, the cash flows are going to be unique from year to year. C02, that value is 66,000, so we input that, and once again, that's frequency. That particular value occurs only once, and so we keep scrolling down. So you'll scroll down and you will input C03, C04, and that will be the last one. Remember, you've got to enter those. Press the enter key to install those values in your in the cell. Well, once you have put in C04, you don't have any more values, but go ahead and scroll down, and it will prompt you for C05, and if you don't put anything in, it's 0, and F05, it'll probably show 1. If you keep pressing down, then it scrolls back around to CF0. In other words, it goes back to the top of the worksheet. You can go back and check your values. It's a great thing about this calculator, unlike some others that will do these types of problems, that, for instance, if you got down to C02 or 3 and you said, man, I can't remember if I put in 53,000 or 35,000 in that for that first year's cash flows. All you have to do is use the up and down arrow keys to move through the worksheet and check what you've got in there. So you can always do that. You can always, by the way, go back in and change some values pretty easily. You just have to install, that is, key in and then enter a different value in that particular cell. Well, once you've got all those values installed, then press NPV. Now, just imagine that what you've been dealing with, when we open the CF, the cash flow worksheet by pressing the CF, it really opened up a worksheet with a single column and a number of rows, and I couldn't tell you exactly how many there are. I've tried in the past. It seems like 20, or I gave up at some point. It doesn't really matter for our purposes. But now what you've done by pressing the NPV key, you've opened up another worksheet, but it only has 2 cells on it. So kind of visualize you've got a little box when you press the NPV key, and that first box that opens up, that first cell, is for your required rate of return, or your discount rate. And so what you're going to do then is to insert or to key in the value. In this particular problem, it was 14%. So key that in as 1/4. In other words, the calculator knows you're dealing with percentages here, so you put that in percentage form, that is 1/4, not decimal form, 0.14, and then press enter. And then you'll see that it shows the IY or I equals, and then it gives the value that shows the value you just put in. Then use the down arrow key to scroll down to the next row. That display now will read NPV equals, and it shows nothing or shows 0 there because you haven't told it to compute. That compute key then is in the upper left hand corner of your worksheet. Of your calculator. So you'll press that, and then immediately you'll see that there's your answer. As I recall, in this particular one problem, the result is a minus 8,238 maybe. Okay, so that's a bad investment. It's a negative NPV. That investment is worth less than it costs. Now, to calculate the IRR, you press IRR. It's only really what you do here. It's opening up a single cell